Right. Hey, everyone. Thanks for joining us for today's webinar. I'm Jana Finch, and I'm the VP of Cloud Institute. And for those of you who are unfamiliar with Cloud Institute, I'll give you the 30-second commercial here. We are a cloud training company delivering cloud certification training and cloud coaching to developers, solution architects, engineers, and other IT professionals. We believe the true litmus test of what makes training successful is when the skills are learned in the classroom actually transfer to the workplace. So that's why we offer challenge labs in most of our products to help you and your team practice and validate real skills, as well as personalized cloud certification and technology coaching. So those specific skills and processes are correctly implemented. Today, we are presenting Multicloud Operations 101 with Zaki Medina. Zaki is a multi-cloud expert, solutions architect, a certified instructor, and entrepreneur running 2 startups at the moment. He has really deep expertise on this topic and is constantly challenging himself to innovate with emerging technologies. So I'm really excited to have him share his wisdom with us today. One bit of housekeeping before we start. Feel free to ask questions in the chat box, either to the group or to me privately. We'll answer as we go along or cover them at the end in the Q&A. And later today, you'll receive a link to the replay so you can rewatch or share with your colleagues. Now, without further ado, I'll turn it over to Zaki.
Thank you so much, Diana. Welcome, everybody, to our Multi-Cloud Operations 101. I know it sounds like a 101 is sort of very fundamental, but really we're actually going to be going into some advanced topics today, right? So the crux of our webinar today is all about basic operations in multi-cloud, right? And the jargon is BaseOps. That's sort of what we're talking about. So we're going to be learning about the basics, how we start with building our landing zone, right? And landing zone will cover what is the landing zone. It's basically the foundation of any cloud environment, right? So before a business can start migrating workloads or develop applications in cloud environments, they're going to have to define that foundation, right? And so in our businesses, well, how do we build the best practices for landing zones? And that's what we're going to cover, some of that from a high level. So we're going to look at the hub and spoke model in Azure, the AWS landing zone, and even definition of projects in Google Cloud, which is sort of the starting block of building that landing zone within GCP, right? So in multi-cloud, this landing zone helps us expand over multi-cloud concepts and technologies, right? So this, we're basically going to be looking at, how do I design the landing zone for the major cloud platforms? And we've kept them to sort of the 3 big ones, Azure, AWS, and GCP. We'll explore the base ops principles for managing. Then we'll also look at some of the design elements of landing zones in Azure, AWS, and GCP. We'll also look at how, once I have my landing zone, how do I define policies to manage the landing zone and get a deeper understanding of handling, let's say, accounts in these landing zones. So we'll also even cover, all these platforms. How do we manage the different clouds, right? Do we do it via just one console, via orchestration, and so on? So really, we're going to explore the foundational concepts that apply to Azure, AWS, and GCP in the context of multi-cloud, right? So, how do we design the basic landing zones in these major clouds? How do we manage the foundation environments in multi-cloud and learn how to abstract policies from resources on the different cloud platforms? So if everyone remembers, anything you deploy in the cloud, whether it be in a network or a compute or storage or database, it's all resources, right? So we're going to look at that. We're going to explore infrastructure as code and configuration as code, right? So sometimes it's called as IaaC or CAC, right? So IaaC and KAC. So those are the term. It's my. I get to butcher 2 acronyms a day. That's my limit. And finally, we'll cover the need for demarcation in the cloud. So some little, philosophical topic at the end of this. So let's get started. Again, as mentioned, we're going off of video right now. We're going to spotlight mode here. But if you have any questions, do put them in the chat, and and we have a separate Q&A section at the end when we go into it. Awesome. So let's jump into it. So base ops, again, a term that's not very familiar, and it's really a play on the word basic and operations. In fact, before we begin, let me ask a poll question to everybody. If everyone can go to the poll side, what is your experience with managing or developing a multi-cloud environment? This always helps us, get gauge the audience familiarity on the topic, and we'll be able to, cater towards what areas. Okay, some experience, great. And that's typical. It's always we've heard of it. We know some of it, but we don't know enough of it. So don't worry. We're going to be covering a lot of that today in our conversation, in our webinar today. So excellent. So base operations, as I mentioned, basic operations. So in cloud environment, there is a term called cloud operations, right? And what base ops does, it's mainly focused about operating the cloud environment in the most efficient way possible. And the way to do that is by making optimal use of the cloud services that the major providers offer at different layers. So we're talking at the network layer, compute, storage, and so on. And even there's also platform as a service and software as a service offerings as well from cloud vendors. So we'll look a bit about that as well. So the main objective, if we think about base ops or basic operations of cloud, is to ensure that our cloud systems are always available for our organization, and then they can safely do the following. Basically, when you think about it, do I have the ability, it's network obviously because I'm accessing the cloud through an external network to the internet. So how do I monitor that network capacity? How do I appropriately route my traffic there? When it comes to compute nodes, how do I monitor the capacity of compute nodes and adjust them according to business requirements or seasonality or usage? How do I monitor storage resources, the capacity in them, and adjust them to business requirements as well? And then we look at other things like availability of resources, including health checks of backups, ensuring that if there is an issue, systems can be recovered when required. We also look at perimeter and internal security of systems, right? We want to make sure that there is data integrity at rest and data for data at rest as well as data in transit. All of these come together when we look at our cloud environment, that there will be a service level agreement that we sign with our cloud vendors, right? And though they will have key performance indicators or KPIs that are agreed to by our business and the cloud vendor or the cloud service provider in question. So making sure all of this works as efficiently, as smoothly as possible is really what base ops is. And then a big part of that base op methodology, or you can call it paradigm, is automation, right? Where can we automate as much as possible so that we can remove some of the tedious tasks. So this is what it comes down to. At the end of the day, it's about the quality of service I'm receiving from the cloud, right? And so this is really, really key for us, right? I would say the most important activity in base ops domain, it's really the foundation of everything else, is this landing zone, right? That we talk about. Now, the landing zone is the environment on the designated cloud platform, whether it be Azure, AWS, or GCP, right? Where we will host our workloads, our applications, and our data resources, right? So this is our starting principle of creating a landing zone. Is we have to create this landing zone and get it fully provisioned through code. That's what makes it very unique, right? In other words, the landing zone just contains the building blocks that can help us define this consistent environment where we can start deploying application and data functionality. And this is really the crux of it, right? When we talk about that. Now, some of you may come up and say, hey, I've heard of other infrastructure where we are combining networking and compute and storage. There's examples like HCI or hyperconverged infrastructure. Some of you may be familiar with that, right? So for some of you that aren't, all HCI is, it's a physical box that holds compute nodes, a storage device, and a switch. And it makes sure that the switch or the networking switch is there so that compute nodes and storage can actually communicate with each other. Again, what is cloud? It's someone else's data center, right? And in that someone else's data center, we're deploying HCI. Now, how is HCI different from landing zones? The only addition would be a router. And a router is needed with our physical box that has compute, network, and storage is that it can allow us to communicate with the outside world, right? And this is really, that's all it is, right? So it's basically, it is cloud, right, at the end of the day. So this base infrastructure, we call it base infrastructure. It consists of compute nodes, storage nodes, and switches to enable traffic, and run routers to route to the outside world, right? So that's all it is. So but all of this is happening in code. That is the big thing. The big thing. I know for a lot of us, especially for me, I come from the on-premise world, have seen the last 17 years of cloud go in front of my eyes. So it's kind of interesting, right? So also to add to this story is that this landing zone is that area that allows us to communicate from our cloud to the outside world and back and forth. But guess what? It also becomes a boundary for access control. So basically, we can provide who needs the accounts, who needs to come in a secure manner, and when they come in, what can they do, right? All of that, that authorization and authentication and privileged access, all of that comes into that into that discussion, right? So basically, a lot of companies would come and say, hey, I'm going to define standards and policies when I set up something like my base infrastructure, like my landing zone. And obviously, yes, there's a million choices to make, but I wanted to give you guys the concepts. The principles are durable. You can apply these in any cloud environment. And in a lot of cases, what we discussed today will be agnostic, right? So let's get started. So as a rule of thumb, there's really 5 elements, right? There's the network, compute nodes, storage nodes, accounts, and then defense or security, right? The good news is for us, all cloud providers today agree that these are the base elements of an infrastructure. Even better, they have all provided, at least the ones I've worked with, which is Azure, AWS, and GCP, they all provide code-based components to create the base infrastructure. So from this point onward, we can call these our building blocks, right? Now, obviously, there's a lot of choice in how to build these building blocks, blueprints, templates, code editors, command line examples, all that. We're not going to go into that, but just staying at that 50,000 foot view is, this is really the heart of the model, right? If I look at this, the heart of the model is, think of the outside circle. I like to think about reference architectures in circles, right? So think about, a reference architecture for your business is to think outside in. So think of an architecture in terms of circles. The outer circle is the business zone where all the business requirements and principles are gathered. And then that drives to the next inner circle, the solution zone. And this is the zone where we define our solutions portfolio. And then if the business has demand for analyzing, let's say, large sets of data, maybe that's a business requirement, then we believe a data lake, as an example, would be a good solution. Or, the new term now is data lake warehouse, right? Which is like a mixed match of data lake and data warehouses. Maybe that's a topic for another webinar, right? So now in the solution zone, we're embedded between the business zone at the outer side and the platform zone in the inner side, right? So for example, some of you, I'm just going to use Azure because I was working on it today. Is that we have this thing called Azure Data Factory, right? And just forget what Data Factory does. It's just a great big ingestion tool for all kinds of data. But really, it's an ingestion tool for my data lake, right? So going back to my previous conversation, hey, what if we have a business requirement for big data or data, right? To ingest lots of data. I need a data lake. So I need a solution. I need a tool. Azure Data Factory will be that, right? So that's an example of a PaaS tool that I can deploy, right? So this is what it is. At the heart of the model, the utmost inner circle is the integration zone where we manage the ecosystem in the other outer circles, right? And so on. And there should be security really baked in each and every layer of the circle. And as a result, you could call that the whole model is set by some sort of intrinsic security zone, right? So this is sort of an example that we're discussing, right? So I just wanted to bring that up with you guys. Um, Again, that sort of sets the stage. So now we know what is the landing zone. We know how to build it. It's our key building. It's our key environment, core environment, base infrastructure environment that we build. So even if we've only deployed a landing zone, there's still a number of building blocks that we will need to manage. And so from a very basic perspective, we have network, compute nodes, and storage nodes. So when we say network, at a bare minimum, right? I'm going back to my networking days. I was a network engineer, and we'd have to look at, for on-premise, we'd have to provision and configure VLANs, right? Today in cloud, these are virtual networks or VNets, right? And VPCs and subnets and internet-facing public zones and private zones, right? And on top of that, we're provisioning and managing our routing, our network address translation, our NAT, and PAT, and network access control, which is NAC, and then access control is ACL and traffic management, right? So those are all the pieces around that. On top of this, we're going to deploy load balancers, network peering, and any network gateways for VPNs, for dedicated connections, and so on. And then obviously there's the whole thing about managing DNS, whether we do that separately, externally through a third party, and then covering this entire network cloud, you could say, is the network monitoring that will help us detect, investigate, and resolve any incidents related to our network function. So that's sort of the network box, right? Now we look at the compute box. So at a minimum, we'll have provisioning, configuration, and operations of our virtual machines and containers, right? This will often, when it comes to virtual machines, it's what kind of operating system are you using? Is it Windows, Linux, various Linux distributions, and so on, right? And obviously, we need to have monitoring, want to detect, investigate, resolve any incidents related to the functions of these virtual machines or containers, and so on, and patch management, any kind of operations of backups. Either we want to do full backups, half backups, iterative backups, snapshots, so on, and obviously the monitoring that goes into logging, health checks, and any kind of proactive maintenance. So this is really, you know, one thing to note is that the compute in the cloud often involves more than virtual machines. In fact, you guys can make a drinking game of this every time I say the word Kubernetes, right? You will want to include things such as containers, right? So containers, containers, containers. So in the cloud, especially when it comes to GCP, it's all about containers, container orchestration, their functions, serverless computing. Those are becoming more and more prevalent terms within a cloud environment, right? We are getting away from the world of virtual machines and so on. So again, our landing zone, these are actually native services, but they're often not deployed immediately. So you'll have to consider when you're deploying a container platform, do you want to do it as part of base infrastructure? And then remember that in the cloud, what we're seeing, side note, a strong shift from virtual machines to containers, right? So again, so you should think about that as well, and prepare. So anyway, so now getting back to our landing zone, as we are deploying our landing zone, and for today, we're going to assume, you know, one of the things we're going to assume is, hey, we're going to deploy using, plus Kubernetes. Kubernetes is just an orchestration methodology and paradigm for managing, orchestrating containers, right? In the Azure world, Azure has something called Azure Kubernetes Service, or AKS for short, where you create a resource group and it will host your AKS cluster. AWS has their version of it. They call it their cluster service, which is called Elastic Kubernetes Service, or EKS. In GCP, this is Google Kubernetes Engine, GKE, right? Now, the good news is a lot of these building blocks, such as Kubernetes, DNS, is already deployed as part of our cluster. That means once we get our cluster running, we can start deploying, cluster nodes or pods. Pods is a term from Kubernetes. All it means is just a collection of my application containers, right? And so on. So that's all, and non-application containers. So this is, again, we can use either the cloud vendors Kubernetes platform, which I gave examples of, um, or we can use third-party ones like Rancher or VMware's Tanzu Mission Control as an example, right? So once we've got all of this, guess what? Now, as I mentioned, it's all about how do I build these building blocks in code, right? So that's the next piece is, in the cloud, we work with code. There's no need to buy physical hardware anymore. We simply define our hardware in code. So it's a very big thing. I'll pause here for a second and just think about that for a second, right? And I'm going back, I have memories of, hey, we need to do capacity planning, back in my old on-premise job 20 years ago or 15 years ago. We need to do on-premise, we need to do capacity planning. Okay, let's plan out the next 3 years, 4 years, 2 years, whatever it is, right? And again, we're estimating. But in the cloud, guess what? There's no need for estimation. Use what we need, right? And so, and all of that can be deployed through code. through software code. And that means that we have to follow best practices of code. That's it, right? That's the simple thing. That's it. And to do that, we're going to take certain elements from software development, right? So because software development has been around for decades and decades, and so we can take some of the best practices and deploy them in our cloud ops environment, right, or base ops environment. So and this is probably the best, most efficient way to do this, right? So you first start with what is called a master code repository, right? This repository, or repo for short, will hold our code that defines our infrastructure components, right? And this is how these components have to be configured to meet our principles in terms of security and compliancy. So this is, what we typically refer to as the desired state, right? So this is something I will keep on bringing up. So what is the desired state? It is where we eventually want to end up when we deploy our cloud environments, right? And it will have all the security and compliance bells and whistles around it, right? Now, Google, AWS, and Azure, they all offer native tools today to facilitate infrastructure and configuration as code, as well as tools to automate the deployment of that desired state, right? That end state we want to get to. For instance, and I go back and forth between all three. In Azure, we can work with like Azure DevOps, right? Or Azure Automation, both of which work with Azure Resource Management Manager, or ARM, right? So, the joke is ARM, or Azure Resource Manager, is the arm that moves the Azure cloud, right? So and it's true in a lot of respects. So AWS offers something else called Cloud Formation, right? Well, Google has something called Google Cloud Resource Manager and Cloud Deployment Manager, right? All of them do basically the same thing. They're all tied to their respective platforms. But guess what? The market also offers third-party tooling that can be agnostic to all these platforms. And we'll look at that a little later in the section here. So for us, it's about the code. How do we keep that code, or that source code management? We can use tools like GitHub, very popular tool, Azure DevOps, or AWS Code Commit, or GCP Cloud Repositories, right? So all four of these are very common, tools that we end up using, right? So again, one of the things that come up around cloud is, how do I define and implement and monitor these management tools, right? So guess what? All these cloud vendors, all of them offer native tooling, right? Azure through Azure Monitoring and Application Insights and Log Analytics, AWS through CloudTrail and CloudWatch. Then you have Google through Stackdriver Monitoring, and so on. And then obviously there's a whole massive set of third-party tools available from Splunk or Nagios. These are some examples, right? So these latter tools have a great advantage since they can operate independent of the underlying system, right? So you're not tied to one cloud vendor. And a lot of companies prefer that, right? So again, I'm not going to convince you that tool A is preferred over tool B. That's something you as an architect, or you're working with your architects, you'll have to decide what fits your business requirements and your budget, right? Those are the two big ones that come up, right? But I want to put out a special report about security, right? I talk about security because it's still not getting through a lot of issues that happen with cloud. Clouds are very secure environments. Let me get that. But there's still things on the human side that are often neglected, right? So that's what it is. Negligence, that's really a big part. So cloud platforms, they spend an inordinate amount of time creating extensive security monitoring on their platforms. They understand if they're not secure, it's game over for them, right? For them, for their customers, workloads, and so on. And monitoring has to go beyond just detecting. It also has to be about triggering mitigating actions. So when it comes to security in the cloud, we're not just detecting a breach, we're going beyond that. In fact, when you think about the time it takes to detect a vulnerability or a breach, and the exploit is really a matter of seconds. Therefore, it makes it very necessary to enable fast action. And so this is where a tool like a security incident and event management tool, or CM, can come into handy. So CM systems have now rapidly evolved to be cloud native, and now basically they're always part of any cloud offering, right? So within Azure, you have Azure Sentinel, which is an Azure native CM tool. It works with Azure Security Center and so on, right? So let's say you have a situation where you can trigger actions right away. So it can block an account then that, let's say, logs in from UK 1 minute and then from Singapore the next minute, and it will basically block that, right? So, this again wouldn't be possible without some kind of warp-driven time traveling thing, right? So that's the thing, right? So monitoring systems have now become very, very sophisticated as a result, right? So finally, one of the thoughts we had, we want to figure out who will be executing all of these tasks, right? Again, this is something you have to look into your own department, your own workflow, and talk about, hey, do I have the right people with the right skills to manage our multi-cloud environment, right? And we have, already said that the truly T-shaped engineer, developer, admin doesn't really exist. That would be a five-legged sheep, right? So most enterprises end up with a group of developers and operators that all have generic and more specific skills, right? And sometimes organizations, they want to take the feedback from this team and deploy it, create a knowledge management piece around it, create a center of excellence, right? You have these things called cloud center of excellences or CCOE, right? So they're an important step in the cloud journey or cloud adoption process of a typical enterprise and showcases their digital maturity, their digital transformation initiative, right? So, bunch of loaded terms, but all I'm saying is that, as you progress through your cloud journey, as you get more and more, you go from cloud to multi-cloud. Eventually, you'll have a COE where you'll be able to have all these best practices and then feed it back to just not just the people but to new members of your team as they come in and leverage the cloud. So this was sort of giving you guys a sense of what that world looks like, right? Now let's jump into how do I start building it, right? So the question is, Zaki, I get that. How do I do it? I need to get to the answer. All right. So if you're like my 8-year-old, how do I do it? I want to start playing it. I don't want to wait. So let's jump in, right? So, creating our multi-zone landing zone, right? So all major cloud providers will offer a methodology that can be used to create a landing zone, right, in our respective platforms. And so in the next few slides, we will explore both landing zone concepts in the context of Azure and AWS and GCP, right? So, you pick your poison. And if you guys are interested in more, if I left out a favorite cloud of yours, definitely there will be an opportunity to add that into the chat and polls as a future webinar. So let's jump in. So I'm starting with Azure here. So if I'm configuring the landing zone on Azure, it's basically I'm leveraging what is called their Cloud Adoption Framework or CAF, right? And in CAF, they've already set out a bunch of things. Hey, these are the set of cloud services you will need to get started on building or migrating workloads to the Azure platform. The landing zone will help create all these necessary building blocks to enable a business to start using, cloud platform, right? So we talk about the analogy of constructing a house in our last webinar or previous two webinars where we discussed scaffolding, right? Where you can consider the landing zone to be an empty house, and the house has to have a foundation, has to have a front door, so you can access the house, and rooms where you can place furniture. And then these rooms are all designed to cater to specific needs. For instance, the kitchen has connections for cooking equipment, tap for running water, and so does the bathroom. It has tap, a shower, and a bath. And there's also a floor that doesn't get damaged when it gets wet, as an example, right? So now let's bring this back. So we compare this to our landing zone. And so it already has rooms that are set up for specific usage, such as can it cater for outside connectivity and so on. So preparing these rooms, right, using our house analogy, for usage is something Microsoft calls refactoring, right? So in the CAF documentation, right, their cloud adoption framework documentation, it will guide the business in setting up security, identity, and access management, naming conventions, and cost management, and so on, right? All these topics are deployed as part of landing zone. So once we finish building the landing zone, we will have a base platform that is secure and defined, a naming and tagging convention for where, let's say, role-based access control or RBAC is in place, and we can have clear insight into the costs that we're generating into the platform. So Obviously, this is important. Why is it important? Obviously, in Azure, everything runs through this thing called a subscription. If you want to deploy rooms, the different segments in your cloud environment will need to host these systems. So in Azure, we typically deploy in what is called a hub and spoke model. What this means is that Azure shares offers shared services, meaning that room can be used multiple times, which is used across different rooms, or services, sorry, can be used across different rooms in this case, or different workloads in our case. So each room is a different workload. That's the analogy there. So for instance, if we want to deploy monitoring, backup services, these shared services land in the hub, and then the spokes connect back from the hub to other rooms or other, services and so on. So that's what it is. The landing zone consists of code. Its infrastructure as a code. It helps drive our Azure architecture completely from code. So from the very start to do this, we use what are called Azure Resource Manager templates, or ARM templates. And these templates are in JSON format. We can actually, so basically when you build an Azure environment, 1,000 servers, 1,000 network, all of that stuff, you can basically output all of that into a large JSON document or file, and that file is basically your blueprint or your template, or your ARM template, and you can actually use that to deploy your second site, third site, fourth site. So that's basically what it is, just a template, right? So this template serves as a blueprint, or the code serves as our blueprint, so we can deploy new, spokes, right? So that hub and spoke model that I'm talking about, so we can deploy new spokes and so on. So that's what this blueprint does, right? So it contains code that will show how the spokes connect to the hub and how shared services are consumed. That's all it is. So, Azure offers various sample landing zone blueprints to get us started very fast on this. So, so if you check your blueprint, make sure when you go through Azure Blueprints, it's actually a thing called Azure Blueprints, and I'll talk a little about that a little later here. But, it will have compliance, security, all of that listed out. So different blueprints will satiate or fulfill different compliance and security requirements. So go through the blueprint, the landing zone blueprint that makes sense for you, for your organization, and then you'll end up, once you get a blueprint, you'll look at, hey, how do I deploy the right type of virtual network with subnets for my gateways? I'll need an Azure firewall. I'll need a jump box, or which is a slang for a management server that administrators can use to enter environments in the cloud, right? And that jump box in the Azure world is called a Bastion server, right? Azure Bastion server. And I'll need a storage account for logging and monitoring, and I'll need to deploy what is an Azure Migrate project, right? So this is sort of high level, you know, of things that we can bake in. So this is basically, this diagram is showing us a basic setup for a landing zone in Azure containing a hub to host the generic services, and then two spokes to host the workloads, right? So these spokes have two subnets, one for management, one for actual workloads for my applications, and so on. So that's basically it. Now let's move to AWS, right? So, AWS actually offers AWS Landing Zone as a complete solution. So more spoon feeding, right? And now that AWS Landing Zone is actually based on a Node.js runtime environment. And like Azure, AWS offers numerous solutions. So basically, the AWS Landing Zone already sets up some basic configuration for us. So it's kind of ready to go. It can and to enable this, AWS Landing Zone deploys the so-called AWS Account Vending Machine, or AVM. And what that AVM does, it helps provision and configure new accounts with the use of single sign-on, right? So that's really powerful for us. So, to grasp this, we kind of also have to think about how we, you know, um, understand how AWS environments are configured. It is somewhat comparable to the hub and spoke model of Azure, but instead of hubs and spokes, AWS uses accounts. And AWS Landing Zone comprises of really, 4 accounts that follow their cloud adoption framework, or CAF, of AWS, right? So at the top, you have your organization account right here. We have our organization account, and then that organization account is basically used to control the member accounts, configurations of the landing zone. It can also include the so-called manifest file, and it stores that in its own S3 storage bucket. The manifest file sets parameters for region and organization policies. The file refers to AWS CloudFormation. That's a service we could compare to ARM in Azure. And then CloudFormation itself will help us create and deploy and manage resources in AWS like EC2 compute instances or even Amazon databases like RDS. And all of them support infrastructure as code, meaning we can deploy all of this through code, right? So, and the good beauty about code is once it's written, it's written. You can just change the settings and configuration parameters and variables, and you can deploy it again once you have great workable code to begin with. That's great. Then underneath this organization account, we have these three accounts: the shared services account, the log archive account, the security account. Now, the shared services account, by default, the landing zone manages associated accounts through SSO. SSO is short for single sign-on. That means you may be using Google Workspace or Office 365 for your Office email. You can use single sign-on with that. So that SSO integration, and AWS managed AD is hosted in a shared service account. It automatically peers new accounts in the VPC where the landing zone is created, right? And the AVM, which is the AWS account vending machine, which provisions new accounts, that plays a heavy role in this, right? And then finally, we have a log archive account. Now, AWS Landing Zone uses CloudTrail and config logs. The CloudTrail monitors and logs account activity in the AWS environment that we create. Basically, it creates a history of all the actions that take place in the infrastructure that is deployed in our virtual private connection VPC, right? So it differs from CloudWatch in that it is complementary to CloudTrail, right? So CloudWatch monitors all the resources and applications in AWS environments, where CloudTrail tracks activity in accounts, and then it logs those activities in an S3 storage bucket, right? So that's sort of the big picture there. And then finally, we have our security account. Now, this account holds all the key vault, the directory where we store our accounts, our secrets, our cross-account roles for the landing zone. We have, two security services that AWS provides. One is called Guard Duty and Amazon SNS. Guard Duty is simply an AWS service for threat detection, and SNS, or Simple Notification Service, enables sending of security notifications. So the landing zone implements an initial security baseline that comprises, among other things, central storage of config files. There's a configuration for identity access management, or IAM, as well, password policies, threat detection, any kind of notifications in the landing zone, right? Now, one thought to use, how does this work? Well, let's say, you use CloudWatch to send out alerts in case, for example, a root account login and a failed console sign-in is detected, right? So that's where we would use it. And so this is what this is, this picture, this diagram here. You know, one thing we haven't discussed yet is the AVM, right? The account vending machine, right? I know it's kind of like, what is an AVM, right? So it plays a crucial role in setting up the landing zone. The AVM launches the basic accounts in the landing zone with a predefined network and security baseline. Under the hood, AVM is simply using Node.js templates that set up organization units, wherein the previously described accounts that we talked about are deployed with default pre-configured settings. So one component that is launched is the AWS SSO directory, which allows federated access to AWS accounts, right? So again, you can just type aws.amazon.com/solution/AWS-landing zone. You'll find a bunch of write-up around this. And finally, let's go to GCP. Now, GCP does things a little differently just because they're Google. They know that. And it differs. In fact, it differs a lot from Azure and AWS, right? And because it's the new kid on the block, it does likes to do different things. So, So although the hub and spoke model can be also applied to GCP, still you can, one thing I found is that platform has a complete different vision of the cloud. GCP focuses on containers, and in fact more on containers than on infrastructure as a service by using traditional resources. So you have your traditional infrastructure as a service through virtual machines and da da da. GCP is like, no, I'm not going to go there. I'm just going to stick to containers, right? So when GCP or Google talks about landing zone as somewhere you are planning to deploy, basically what they think is, hey, you are talking about a landing zone. What you're really talking about is deploying a Kubernetes cluster in a GCP project using GKE, right? Although you can deploy VMs, of course, but yeah. So in the landing zone for this is a plot. You create what is called a virtual private cloud or VPC network, and you set your Kubernetes network policies. And that's it. So Google does make it a little easier, but it's also a little confusing because if we are working on multi-cloud, that's why it's something I personally, I like to do all, I have a different cloud setup which I'll share with you. I actually use all three clouds in other companies of mine, other environments of mine that I run. I use, combination of all three. So anyway, these policies, so going back to GCP is you create your VPC, you set your Kubernetes network policy, you define the policies that you want, right, for both your isolated and non-isolated pods in your Kubernetes environment, and then you attach your network policies, right? Basically, what a pod is just a number of containers which only allow defined traffic, right? Whereas non-isolated pods basically accept all traffic from any source, right? So this way you can use that policy to assign IP blocks, some kind of access list for deny, allow rules to the pods, and so on, right? So that's all it is. Who talks to what, right? So it's just the network traffic you want to manage and monitor. The next step is to define service definitions in my Kubernetes environment, right? So this service definition, it will help my pods, which are those containers, with a collection of containers to actually run either applications or databases, right? Whatever it is I want them to run, right? Now, as I mentioned before, Google very much advocates the use of Kubernetes in containers. In fact, they invented Kubernetes. So yeah, obviously. And which is why GCP is really optimized for running this kind of infrastructure. I mean, this is really what Google's been running in their backend. So they're like, hey, if it works for Google, it will work for anybody. That's sort of the mantra. And if you don't want to use container technology, then you will have to create a project in GCP ourselves. And this is sort of the preferred way, right? If you don't want to do it, you can use something called a deployment manager and then use the G Cloud command line, right? So you can deploy deployment manager in GCP, which is similar to ARM in Azure. It uses APIs and other GCP services to create and manage those resources on the platform. So this is one way to access this through the Cloud Shell within Google Cloud Portal, right? So GCP actually has some nice tools. Don't get me wrong. I kind of like GCP for that. For especially if your people, if your admins love Unix or command line programming, they will find it very recognizable and easy to work with, right? So the first step to enabling these APIs, that is the Compute Engine API and the Deployment Manager API, right? So by installing that Cloud SDK, we get a command line tool called a G Cloud and so on. So all of this, again, once you get it set up, you're done, right? So you can basically then clone different samples of your deployment manager and so on. So that's really the power there. So in this diagram, what we've done here is just a basic setup for a GCP project. We've created landing zones in all three. We have we're just creating our GCP using Compute Engine and Cloud SQL and so on. So basically what we've done here is and if you're interested to learn more about Kubernetes, guys, thank you, Diana, for pointing out. We actually have a huge discount running on promo running on our 22 Kubernetes challenge labs here. So if you guys want to check it out, definitely do check it out. Again, this will help you build your expertise in Kubernetes. So, we've looked at all three landing zones or major cloud platforms, and we've discovered the way some of them are similar and not similar, right? Now let's look at some of the ways we manage them, right? And this is sort of high level, right? When we work with cloud platforms, we work with code, right? That's something very important to understand. Everything we do in the cloud is software and code defined. This is what makes our cloud infrastructure very agile and means, but it also means that we need to have some strict guidance on how we manage that code, starting with the code, how it defines our landing zone, and so on, right? And as everything with IT, everyone knows it needs maintenance, right? So if I'm managing, let's start with AWS now. So in AWS, where AWS has something called Cloud Formation Guardrails, again, very appropriate name because it literally keeps your environment, your cloud environment, on the rails, right? So guardrails comes with four principal features, and all of these policies are set in JSON format. So great big JSON file, you can think about that. So to create policies, AWS offers what is called a policy generator. It's just a form you plug in. You basically define the type of policy first, and then you define the conditions, and then meaning that the policy should be applied. And in that policy, you would talk about termination protection. And this is basically, Azure talks about, how do I take the collection of AWS resources and how can I manage them as one unit from the AWS management console? So that unit is sometimes called a stack, which is a collection of AWS resources that have the same type of management overhead. So that stack can be an application that comprises a front-end server, a database instance, maybe using S3 bucket and network rules, right? And so on. So now we enable these termination protection, and we prevent any kind of the stack from being deleted unintendedly, right? And so termination protection is disabled by default and so on. We have deletion policies, right? The next one is deletion policy. So this is where, if I have termination protection in place for my entire stacks, then these detection policies will prevent, it will have basically help me, it is set per resource. So if something is deleted, do I want to retain it or not? Do I want to keep an attribute of it in my AWS account? It will have all of that. Or should I take a snapshot of it whenever I delete it as a best practice, right? So that's an example of that. Then we have stack policies, which are basically define actions for the whole stack or group of resources that I can, as an example, I can, there's an action where I want to update all my database instances, right? As an example. And then we have our identity access management, who gets what, who's allowed to do what and when, right? So this access control can be set with very fine granularity for whole stacks, resource groups, or even a single resource, right? So you have your single resource groups, and then stacks, right? So that's sort of the hierarchy there. And then let's look at Azure. Azure, as we mentioned, right? It does the same thing. Azure actually is very interesting. They have this thing called test-driven development, TDD. So they're actually taking a big page out of software development, test-driven development. For a lot of you, what that means is in software development, we write the test first before we write our code. So that helps us, make sure that our code always passes the test, right? So that's a principle. So this TDD paradigm or principle is sort of adhered to in Azure, right? As well. So Azure provides these tools that support TDD and helps in the process of what they call refactoring, right? So even the word refactoring is taken from software development, where you look at the code and then you refactor the code, meaning you make your code more optimum, more efficient, and so on. So the same thing, you do the refactoring on the landing zone through Azure policies, where we say what are the business rules, what are the cost parameters, security parameters, or cost thresholds, and so on. And we can apply that policy at the resource level, resource group level, and so on. And then we have blueprints, and blueprints are basically where it's already built, the policies, initiatives, and deployment configurations, all built in one package. You can copy that, change a couple of things for us, and reuse it, and so on. And Azure offers, again, as I mentioned, various blueprint samples. So make sure you find the one that adheres to your compliance and security regime. And the good thing is that these can all be easily imported through Azure DevOps. So if you have a CI/CD pipeline, which is continuous integration, continuous deployment pipeline, another DevOps pipeline, you can ensure you always have consistent code repository right from the start. We also have Azure Graph. This is a new one. This is deployed based on the principle of refactoring. So you're deploying various iterations and so on. And basically what Graph does is it creates test sets to validate the configuration of the landing zone. So Azure Graph comes with query samples and so on. So, you know, it's something to deploy. And then the best part of all of this is, if all of this is too confusing, you could just go get really started, is deploy the quick start templates that have all of these above already ready to go, right? So you could just change some of the default settings for your landing zone and away you go, right? So that's one awesome option. And then finally with GCP, as I've probably seen, GCP does things a little different, right, in terms of public cloud and landing zone. And again, it's based on Google. They have this focus on container technology using Kubernetes as the management orchestration layer. So what Google does is it offers extensive possibilities in setting policies for your environments, right? So it does these two things. It does organizations in and resource policies. So at the organization level, in GCP, we set policies that use constraints, and a constraint is really an attribute, and that attribute is part of our service definition, and then that service definition. So, okay, I'll give you a quick example. Let's say you take a compute engine, and that compute engine deploys virtual machines or VMs in your GCP project. Great. Now that compute engine project um, there is a logging enabled, by default for all the operating systems. So we can enable this and set a so-called Boolean constraint code named, Boolean named after my friend George Boole. Just kidding. And then basically what we can do, we can set the compute engine to true. So next time we set a policy, it will prevent that policy from preventing, the logging from being disabled, right? So that's what it is. It's a lot of, toggle yes or no kind of deal. And so if you want to learn more about organization and policy constraints in GCP, you can just type org policy constraints here. Then you have resource policies, and these are basically cloud. These are Google resources that leverage JSON or YAML files for its IAM policies. So every policy is defined by bindings, an audit configuration, and metadata. And it's basically each binding consists of a member, a role, and a condition, right? So how does that play for each resource, right? So that's sort of the high level. Again, we're running out of time, but I want to leave with you a couple of things here. When we're orchestrating these policies, so we've looked at many ways we understand how landing zones work and looked at some of the management policies around that within our major cloud platforms. But guess what? We're going to want to have a single repository or single repo where we store and manage all our policies, right? It's very important. All cloud vendors basically support JSON as a programming format, right? So it's very important to note, right? So the problem is that these platforms also have different concepts of deploying policies. But so what is the solution to this, right? So to think of a solution, we started thinking in terms of layers and abstract logic from the code itself. What do we mean by this? We mean that the policy has a certain logic. As an example, we must define that all VMs in our environment must be hardened following certain guidelines, right? As an example. And now, what type of VM are we talking about is irrelevant. So is the operating system. But the way to do that is by deploying this common, recommendation, right? And that's where we have third-party tools like Terraform, right? So HashiCorp is the company, Terraform is the application. What Terraform does is abstracts policies from code so it can deploy the infrastructure as a code on various cloud platforms from a single source of truth. This is awesome. Guess what? It's one management layer for my multi-cloud environment. So whether if I'm using all three clouds or five clouds, I can just use Terraform across all of them, right? And then there's Terraform, and then a friend of mine recently told me about another great tool called Pulumi, right? So check it out, right? These are some great tools that will help you deploy, you know, this. So basically the point here is to understand is that, hey, I want to get to my desired state, right? So let's look at this diagram here. This diagram basically shows us, you know, it's a very simplified model of our desired state, right? So if we use Terraform, so Terraform, in the form of YAML files, it'll have its own syntax, unique syntax, where it will allow us to fully abstract resources and providers. It will help us define a block for any type of resources, from whether it be a VM or a container. It will tie in the DNS information and so on. And this Terraform uses a language, it's the HCL or HashiCorp configuration language, right? That's their term, but it's really just glorified YAML file, right? So, that's what it is. It ends up doing. So now Terraform will apply these blocks to the cloud, and at the same time, it'll create this so-called state file, and that state file will be used to apply future changes to the infrastructure in an ongoing manner. So basically, from my code repository, for instance, GitHub, I can start pushing these builds out into my infrastructure in real time. I can schedule it, make it automated, all of that good stuff we can do, right? So this is really, really powerful stuff, right? So again, you know, there is a whole thing around the need for demarcation, right? Within the cloud is how do I, typically when we talk about demarcation in cloud, we need to deploy, you know, now we've talked about landing zone, but how do I deploy this? Who's responsible for what? And that's where we need to decide, you know, where are we deploying this? Is it my headache or is it my provider's headache, right? So that's something you'll have to talk about with your cloud provider. You'll have to see where do you fit in that infrastructure as a service, platform as a service, SaaS as a service, right? And so on. So that is a conversation that has to happen. What does the cloud provider do? What do we do? And then based on that, you will develop your own, controls and deliverables. And this is just a sample one. I'm not going to go through it, but just to give you an idea of what are the things you'll end up building in this, right? So again, to summarize, we've defined and set up our landing zones from different cloud providers. We looked at the foundational principles. We explored infrastructure as a code and configuration as a code. We looked at tools like Terraform to manage our multi-cloud from one code base. We even learned how to define policies in all of them and so on. So all of this adds to that BaseOps thing, right? And finally, we learned there's a need for redundant demarcation model in multi-cloud. So that's it. That's our question, our webinar for today. I want to thank you for joining. We have a few more minutes if people want to stick around and ask any questions. Let's look at this. So there is one question here.
Yeah, we've got one in the chat from Rhonda. She asked, for Terraform, can you run a script to update all 3 platforms at once based on a standard security change? Or would you have to manage each change separately?
You'd have to manage each change separately, and only because, but you can run one script, but you have to do it, not in sequence. You could say that, right? So that's probably the way.
Okay, hopefully that answered your question. No other questions right now. But thank you for joining. That was really enlightening. Certainly above my skill level with multi-cloud as a marketer, but I learned a few things. So thank you all for joining. There will be a replay link sent to you from Demio here in the next couple of hours. If you have any questions or any feedback, my email address, jana.finch@cloudinstitute.io, is all over your webinar reminders and registration info. So feel free to reach out to me or Zaki. Thank you for joining us.
Thank you. Have a good day, everyone.
Okay, bye.